I've been looking forward to this talk for quite some time. I really enjoy talking about this journey about how we migrated from EC2 virtual machines onto Kubernetes. Before I do get started, that QR code that's up there, that will send you to my LinkedIn profile. If you're curious, you want to get connected with me, you can also see all my contact information up there. If you have any questions after this or not unable to get to, or just in general, feel free to reach out to me. I'm just happy to talk with you a little bit more. So this story is a brownfield migration story. We're going to be talking a little bit about how we moved from hundreds of EC2 virtual machines onto now we're running thousands of dedicated container instances for each of our customers. But then I also do want to talk, as we mentioned earlier, about the challenges of managing thousands of customers on Kubernetes clusters. This is not a sales pitch about Octopus Deploy. I don't want it to be a sales pitch about Octopus Deploy. However, you have to learn some things about Octopus Deploy for the background context. We are a tool that does deployments. I know that's a big shock considering the name. But at the same time, we have both a self-hosted option as well as a SaaS offering. We have a .NET application, that's one of our 4 key components, as well as SQL servers, our database backend, file storage, and then when I talk about networking and load balancing, I'm talking a little bit about the ingress into the application itself, as well as the egress when we connect to the various Kubernetes clusters or virtual machines or PaaS services that we need to deploy to, along with all the communication between all the different components. So I want to talk a little bit about Octopus Cloud v1 and how we ended up with hundreds of EC2 virtual machines. It was a very deliberate choice. So Octopus Deploy as a company, we've been around since 2012. And when we first started, we gave our customers an MSI and they installed it on their Windows servers. And for a time, everything worked great. But as happens when you give an MSI to a customer, they install it on their own servers, and then they eventually start running into support issues. And so they'll email us for support, and we help them out. And so we started building up this library of knowledge. Around, I want to say, early 2017, we started hearing from our customers asking us, do you have a SaaS offering? Could you offer a SaaS offering? And we thought about it, and we thought about it. And we said, we're starting to hear more customers ask for it, but we're not still 100% sure. Is this something that every customer wants, or is just a small minority of our customers who are really interested in a SaaS offering? And we also were concerned about the effort to rewrite everything. When you go with a quote-unquote cloud native, going from a standard .NET application, make it cloud native, that could be a pretty big rewrite. So we opted to follow the path of least resistance, but still offer a SaaS offering. So we took all of the knowledge that we had built doing supporting our customers for self-hosted, and we said, all right, let's put that in the cloud. Let's put that on AWS. And so we started in, give or take, September of 2017. And then in July of 2018, we went live with it. And turns out the demand was there, and it was actually better than we hoped. A lot of customers started signing up for Octopus Cloud. Like, this is really great, we're seeing all this demand. And then August came, and we got our first bill from AWS. And I can't give you exact specifics as to the dollar amount, but what I can say is that if you use 2018 housing prices, I could have paid off my mortgage. So very, very concerning when we got that first bill. So this brought us to our first lesson when it came to doing a digital transformation like this. Cost can be a deciding factor, but it shouldn't be the sole deciding factor. In fact, it was a driver for us. What we needed to do is we needed to reduce our costs. And the only way for us to reduce our costs was to increase customer density and improve our hardware efficiency. And we did this because we were looking at all of our instances over multiple months, and we're saying at no point did we ever see a situation where a single EC2 virtual machine was at 100% resource utilization 100% of the time. Sometimes it would be at 90%, sometimes it would be at 10%, and that was true for all of our customers. Another challenge that we really had was how do we incrementally increase these compute resources? Some customers, they were perfectly fine with the 2 virtual CPUs and 8 gigs of RAM we gave them. Others, they might have needed 10 gigs of RAM or 11 gigs of RAM. But anyone who's worked with any sort of cloud provider knows that you don't incrementally increase the resources, you double the resources. So you go from 2 virtual CPUs and 8 gigs of RAM to 4 virtual CPUs and 16 gigs of RAM. Now, when we decided on adopting Kubernetes, one of the more interesting things that I forgot about until I asked our cloud platform team, we initially didn't consider Kubernetes. You have to remember, this is 2018. And we thought of a bunch of different options. Could we run multiple Octopus deploy instances on a single virtual machine? Yes, that is possible. I know of customers who are doing it right now. However, the challenge that we ran into with doing that was twofold. We had the noisy neighbor effect. And if you're not familiar with that term, what it means is when you have one particular customer consuming all of the resources and any other customer that was on that virtual machine had a substandard experience. The other challenge was the security. That was a big concern because how do we guarantee a situation where one instance can't see another instance's resources? Could we rewrite Octopus deploy to run on serverless? That was an option as well, and in fact, that's what AWS told us to do. I'll just rewrite everything to run on Lambdas. Okay, that won't be very expensive to do and very time consuming. Why we ended up turning that option down was because we still have a significant number of our customers who are still self-hosted. They're still running on Windows servers. And so we would end up in a situation where we'd have 2 different code bases. So I said, that's not going to work. There we go. So let's talk about some of the Kubernetes benefits and why we started looking at them. We got that improved hardware efficiency, which was really important to us. We also got that design for scale for Kubernetes. We were looking at some of the other container options because containers was definitely becoming more and more of an option for us. And we're like, well, I mean, you could do ECS, you could do ACS, but Kubernetes just felt like a better fit for our use case. We got that incremental resource scaling that I was talking about. And then we also got additional benefits that we didn't really consider was important, but became much more important later on, specifically around that desired state and immutability. We were doing a lot of that immutability already out of the box because anytime we released a new version of Octopus Deploy, we were building new AMIs, and that's what we were rolling out to our customers. We weren't just upgrading the same EC2 virtual machine over and over again. So we were doing a lot of container-like activities, but we weren't using containers at that particular point in time. An additional benefit to us was, as a company, we had added Kubernetes support into Octopus Deploy at that particular point in time. And so this gave us a chance to dogfood it. And we knew if it worked for us, chances are it would work for our customers. If it didn't work for us, there's no way it would work for our customers. So it gave us a really good chance to dogfood our own integration. So I want to talk a little bit about migrating to Kubernetes and what that experience is like, especially for a brownfield migration. Now, we had been providing our customers for years Windows containers. Now, a little bit of audience participation. Sorry, I can't do anything at home, but raise of hands, I'm very curious. Just raise your hand. Are you running Windows-based containers in production today? Is anyone? Okay, no one. That's exactly what we ran into as well. That was our big concern. We would be the only ones running Windows-based containers. And the truth of the matter is at that point in time, none of the managed service providers, EKS, AKS, I don't think even GKE, supported Windows-based containers. So we opted to migrate to Linux-based containers. This provided a couple of additional benefits outside of having widespread support. Even a small thing like the size of the containers. I still want to know what was going on with that one container that was 6.83 gigs for Windows compared to 675 megs. But we started this migration process in September of 2018 to build this Linux-based container. And that's really what took a significant amount of time for brownfield migration. Anyone who's considering a brownfield migration should know you're going to have post-migration issues. They will be very surprising, and you can't plan for them, but they will be there. So initially, we knew of all of the issues we could anticipate. We knew that we had to update all of our third-party libraries, or we had to find replacements, because we would go to certain third-party libraries, and they weren't planning on adopting, at the time, what was known as .NET Core, now it's just .NET, for another year. It's like, well, that's not an acceptable time frame for us. Or, sadly, some of them had been abandoned, and they were no longer being maintained. And that was a big concern for us as well. We are also referencing the Windows registry for a couple of settings, thankfully not for everything, but we had to find a replacement for that that would work for both Windows and Linux, because we still had to support all of our self-hosted customers. And that was one of the biggest challenges, is how can we continue to support our self-hosted customers while still providing a Linux-based container? Then you had the fun stuff where we had to verify all the file system information. So we store items in the file system that we can't store in the database, such as jar files, WAR files, containers, NuGet packages, zip files, deployment logs, artifacts. We had to verify all of that functionality still worked. And then came testing, which is everyone's favorite thing in the world to do. It's just test, oh, it failed. Test, oh, it failed. Fix, okay. But then we had a version ready to go in July of 2019 for Octopus Cloud. And we were really happy with it. And it was working as well as we hoped. But then we started running into some post-migration issues that we had not planned for. The first one was around Active Directory authentication that our self-hosted customers ran into. Even though they were running Windows on Windows Server still, they weren't running containers. Because of this migration, we ran into that issue. The most insidious one for us was the Microsoft SQL client. What would happen is, very randomly throughout the day, our containers would just restart themselves. And we're like, what is going on? And we're reaching out to Microsoft and asking them to help us for this problem. And this was such an issue, and it was happening to a lot of other customers that a lot of people weren't seeing. But eventually, the register picked up on it. They even interviewed one of our senior developers about this particular issue. And we still had to work through that final solution to get to that problem. So it took us a while. And it wasn't until a year later that we had something that we could give to our customers to run on for their self-hosted containers. So we had July of 2019 where our customers, we could have Octopus Cloud, but it wasn't until August of 2020 that we had something that we could give to our customers to run. Now, the big thing is we didn't have the same staff of R&D. We had a massive staff for the initial migration, and then that shrank down to maybe 1 or 2 people that were just focused on pushing this last effort across the line. But the big thing for us, and this is what our VP of engineering constantly said to us, the phrase he used was, you had to build the plane while you were flying it. We couldn't go to our customers and say, we want to go to Kubernetes, we want to migrate to Linux-based containers. Guess what? We're going to stop building new features. We're going to stop fixing bugs. We're not going to issue any security patches. That was not an acceptable answer. And so as much as we wanted to devote our entire R&D staff to this conversion, the simple fact of the matter is we couldn't. And we still had to support of all our paying customers in doing this. So this was just a recurring mantra. We had to continue to build the plane. So every time we did this conversion, every improvement that we made, we had to make sure that it continued to work as is for our existing customers. Now, this is probably a very controversial lesson at ContainerDays, but Kubernetes and containers didn't make sense for all use cases. So I mentioned that we had 4 components. We have Microsoft SQL Server, and we have file storage. Microsoft SQL Server, they offer a container-based image. You can run it on Kubernetes. Raise of hands as well. Is anyone running Microsoft SQL Server as a container in production? I'm just curious. Still no one. All right. I will get someone to raise their hand eventually. Is anyone running a relational-based database, Postgres, MySQL, Maria, Oracle, if you want to do that, or SQL Server as a container in production? Is anyone doing that? We have a couple people, a little bit more than I okay, good. But not a lot of people are doing it. It's not a majority thing. And I know that there are use cases for doing that. Same thing with running file storage inside of a Kubernetes cluster. But for our particular use case, it didn't make sense. And we quickly dismissed these ideas. And I'll get into one of the benefits of why when we made this decision, how well it worked out for us in just a little bit. But the big thing for us is we were not database experts. Anything that we wanted, we would have to build if we wanted to host a database as a container. And so we opted for cloud managed services because we were running our Kubernetes clusters on a cloud provider. It made sense. We wanted to leverage their expertise, and it was already built. And we also got additional functionality out of the box without us having to do anything, just a few configuration changes. We could have built all of that, but at the end of the day, it would have gone on a backlog. It would have been picked up in 12 to 18 months, but we could get that today. And so we opted for that. We also had to move workloads that couldn't run on containers. So I mentioned that we ran everything on EC2 virtual machines, and there were Windows-based machines. One of the most popular scripts for Octopus Deploy, steps, not scripts, steps, is the ability to run a script step. And at the time, the vast majority of our customers were running PowerShell scripts. And they expected them to run on a Windows server. They had written it to do that. And so we had to run or create these Windows dynamic workers. These are very short-lived virtual machines that would be destroyed after a set amount of time. So the Windows-based Windows-based worker was launched in 2019, whereas the Linux dynamic worker, that was launched a year later, because at that point, PowerShell Core had come out and had been much more popular. Then we could also much more easily support Python as well as Bash. It just made a lot of sense. But then we learned not all managed services are the same. So we were running on AWS. And we're using AWS RDS as our database backend. But if anyone who has tried to increase density on AWS RDS instance will probably run into this issue where they have a finite number of databases that you could add. And we would do research and we would see that at no point were all of our databases in a situation where we're consuming all of the resources collectively. And after a lot of research and a lot of different options, we chose to move to Azure and leverage the Azure SQL Server and their Elastic SQL pool because it made sense for our use case. I'm not saying everyone should do that. I'm just saying that evaluate your own use cases and do what makes sense. Hopefully your company hasn't signed a cloud agreement where you have to spend, you have a certain minimum spend. We hadn't done that yet, so we could change. All right, so I want to talk a little bit about Octopus Cloud V2 and what it looks like running Kubernetes. So I know we said 1,800 earlier. I updated this number recently because it grows. Now we have about 1,900 customer instances. The number fluctuates, sometimes more, sometimes less, hosted across 3 regions. We have 8 Kubernetes clusters across those 3 regions. We leverage virtual machine scale sets, where we have anywhere from 3 to 6 nodes. Most of the clusters in America have about 5 to 6 nodes most of the time, whereas the clusters in Australia are hovering around 3 to 4 nodes. Sometimes it goes up to 5. Each node is big. We're talking 20 virtual CPUs and 160 gigs of RAM. But with that, we can do about 300 to 500 instances per cluster. Oh, okay, that diagram actually turned out better than I hoped up there. Every customer instance, they get a dedicated container running in a separate namespace. We have a dedicated Azure SQL database for each customer, a dedicated Azure file share, and then they get dynamic workers on demand with that. So now that we kind of understand a little bit about our Octopus Cloud setup, let's talk a little bit about what it's like to manage clusters at scale and when you have a SaaS provider like this. And this was one of the more ongoing challenges that we have. So we finished this migration in 2019, but we've had an additional 5 years of running Kubernetes where we've learned a number of different things. One of the big things that we learned was operational work shouldn't be a part-time focus. One of my favorite things about DevOps is the mindset of eventually we're going to give you the tools and the processes and the capabilities where if you build software, you're going to have the capability to own it. And you can help make sure that it's always running. You have the power to deploy to production. And then eventually maybe you'll get an embedded engineer, like a DevOps engineer or an operations person in your team. That's kind of the ideal shape where you have self-managed teams. And then any overflow work goes to the developers. And that was the way that we were working. We had one dedicated person, and that poor person, I felt, it was like the old cartoons running around trying to plug all the holes. I felt really bad for him. And we quickly learned that that was not going to work for us. Because you have to understand, we have 1,900 customer instances. This means we have 1,900 containers, 1,900 databases, 1,900 file shares, and 1,900 network configs that we all have to make sure is working 100% of the time, all the time. And we couldn't have one person doing that. We needed a dedicated team. And so we have a very large, what we call cloud platform team. And their sole purpose in life is to make sure that we can support all the different use cases that we have. So we have some customers deploy every 3 weeks, and when they do those deployments, there are thousands upon thousands of deployments. We have other customers that are doing thousands of deployments a day, some that are doing 100, some that are doing dozens. But we have to make sure we can support all of their different use cases. And so having a dedicated team focused to doing that and focused on the resource management is really important. One of the things that they quickly identified was we needed to write some custom tooling. And this was a bit controversial because there's all this great tooling that's out there. But as we researched it more and more, we said we would be really misusing a variety of different tools. And we needed to write very specific tooling for our business requirements. So we wrote what was called the Cloud Portal. Now, the Cloud Portal is a custom internal tool that only Octopus Deploy employees have access to. And it's a one-stop shop for anything that's related to Octopus Cloud. And this is what enables us to manage customer instances at scale. One of the big things that it provides to us is this concept of day 2 operations. The screenshot on the left, that's a 3 to 4 day time span of my personal instance and how often it gets upgraded. Now, we have different upgrade rings. We have internal staff rings, which gets upgraded as soon as a new version is ready. And then we have kind of an alpha ring, and then we have the stable ring for everybody. Because I'm on a staff ring, I'm getting new versions all the time. That's why you see upgrades sometimes happening multiple times a day. We don't do that to our customers. That's crazy. But then on the right, the other screenshot, that shows all the other maintenance tasks that you just have to perform when you're running a SaaS operation like this. Rebuilding the database indexes, backing up, file storage, performing upgrades, any of those types of tasks. Without a tool like this, we would be unable to do this at scale. The other big thing is we had to respect our customer's maintenance window. Being a deployment tool, we have to make sure that Octopus Deploy is running for our customers when they need to deploy to production. The last thing that they want is for us to do an upgrade to their instance in the middle of their key production deployment and causes all kinds of failures. So we set a maintenance window where the customer can just say, during this time frame on these days, I won't do any important production deployments. And then during that time, we can do work like upgrades or database maintenance. But we also have guard clauses in place to make sure we don't perform unnecessary maintenance. We're not going to rebuild their index if it's less than 5% fragmented. That just wastes everyone's time. We also had to stop noisy neighbors. Now, I mentioned that we had the concern of how one customer could consume all of the resources. So we set the CPU and RAM limits and requests and everything like that. And we also have database limits in place. But some customers, they need more resources because they're doing a lot more deployments. Now, we can't, again, do this manually where we're evaluating every customer's resources. What we have to do is we have to use the CLI, and we have to use Azure and anything else that's available to us where we look at their resource consumption. And if it meets certain thresholds, we start incrementally increasing their resources. Conversely, we'll start decreasing resources if they meet other thresholds. And we had to build that to make sure that we stopped the noisy neighbors but still provided a very performant experience. Upgrading clusters. So I mentioned that one of the benefits of using cloud managed services was we don't have to run those items in Kubernetes. And when it came to upgrading clusters, it turned out that was the right decision. So the way that we upgrade our clusters is we spin up an entirely new Kubernetes cluster. And then we will move the customer's instance over to the new cluster during their maintenance window. Because we're using managed services, that's really easy. All we have to do is just point at the Azure SQL database and Azure File Share, and that container is moved, and it takes a couple minutes at most for each instance. And so this enabled us to do it. But the Cloud Portal is the tool that enables us to do this migration and this upgrading. Finally, we have the billing system events, where you have these things that happen. So for example, a non-payment occurs, and we drop it in the message bus. Cloud Portal sees that message in the message bus and goes, oh, they haven't paid? Well, I'm going to deactivate their instance and move everything to cold storage. And then we have another process that comes through 150 days later and says, how long have they been in cold storage? Oh, they've been in cold storage for 150 days. Go ahead and delete them. But that being said, I'm not against third-party tooling. Evaluate it and use third-party tooling whenever it's feasible, so you're not rebuilding everything. Now, there's no big surprise when it comes to deployments, how we're deploying our own software. We use Octopus Deploy to deploy Octopus Deploy in this weird snake eating the tail type of situation. And by doing that, we can have one set of YAML files and one process to deploy to thousands of customers. So big benefit for doing that. But we're also using a variety of other tools that enable us to manage these customer instances at scale. We're leveraging Sumo Logic and Seek to capture all these different events and logs. We use Grafana for dashboarding, so we can get a quick overview of what the customer looks like. I think Grafana's been replaced by Sumo Logic. I'll have to double check that, but we're also evaluating all the tools as well every single time. We use Better Uptime and PagerDuty for uptime notifications and sending out pages to our support people as well as our cloud platform team. And then we're ingesting all of this data into Snowflake. And so we can look at a variety of different information and say, okay, that customer during this time frame cost us this much money to host. That customer during this time frame had this uptime. So when it comes to a summary of some of the lessons that we learned by migrating to Kubernetes, when we decided to move to Kubernetes, cost shouldn't be the sole deciding factor when you make this decision. It can be a driver to improve, but it shouldn't be the sole deciding factor. Once you make the determination that you want to do a migration, brownfield migrations, if you decide to do that, and it made sense for us because we had to support both our self-hosted customers as well as our cloud customers, you will have post-migration issues. Just be prepared for that. And you don't have to migrate everything. Kubernetes and containers doesn't necessarily make sense for every single use case. Do what makes sense. Now, I know of customers that are deploying Kubernetes clusters to restaurants and factories and any number of those edge locations where it makes 100% sense to run containers as databases. I would do the same. So do what makes sense for you, your use case, not necessarily what everyone else is doing. But if you do opt to do managed services, they're not all the same. Some have pros and cons, and that's perfectly fine. When you're running Kubernetes at scale, just note that operational work shouldn't be a part-time focus. Custom tooling might be required for your operational work, and if you do leverage tooling, use third-party tooling whenever possible. It's okay to write some custom tooling, but not everything. And that is it. That QR code will send you my LinkedIn page. Thank you very much.
Perfect. Thank you very much. And we have some time left over for questions, so I always love when that happens. We have one question already for you. How much of the Octopus code had been refactored during the journey to make it work?
Oh, that's a good question. It wasn't as much as we thought. I think the majority of the code was migrating to .NET Core, as opposed to migrating just specifically for Kubernetes. I would probably put it in the realm of maybe 10 to 15% at most, but we had to change it or touch it or verify it for a variety of different reasons.
Right. As a follow-up question from me, myself, did it help with finding talent to move to a different kind of stack? Is that something that was a consideration maybe as well?
That was a big challenge because the vast majority of people who worked for us at the time didn't have Kubernetes expertise. And so a lot of people had to learn on the fly. I would say a significant number of our engineers, they're still with us that were here in 2019 when we did this migration. That's why I can ask them these questions.
So they went on a learning path.
They went on a learning path as well. And so our cloud platform team were hiring Kubernetes experts as we went, but it was a case of some people are learning on the job, but we had to hire experts as well at the same time.
And finding resources to upskill people, was that that seems like a lot of work.
That was a bit of a challenge. Thankfully, we had added our own Kubernetes integration, so we had some of those resources. We had already learned some of those resources. One of our biggest challenges is that we're based in Australia, and so that's where all of our R&D is located. So hiring all the people, finding all the resources as well in Australia was a bit of a challenge.
Right. Yeah, I can imagine. And also, like, remote work with such a time difference might be a bit of a challenge. All right. I think that's it for questions, unless, Slido is cheating me again, which is very possible. Okay. Thank you so much. Let's do one more round of applause, and then we can all switch rooms or, stay here. You're welcome to stay here for the next talk that is starting in 10 minutes. Thank you.
Thank you.